I'm really honored to intro our next guest. Without him, the internet would not be what it is today, which kind of scares us, but I'm sure we'll learn a lot about that in a second. Paul Mockapetris is an internet advocate and investor. He's best known for being the creator of the domain name system, basically DNS, and he'll tell you more about that. Also for creating implementation of SMTP, the first implementation. Without that, email wouldn't be what it is today. As I mentioned earlier, yesterday, I always ask people their mission, in line with our theme here of what matters. He wants to make changes that matter. And his title is Be Careful What You Wish For. Paul, come on up on the stage. Take it away.
All right. Good morning. Let's see. Oh, we're up. All right. Alistair asked me to come and give you a talk about the DNS and my experience with it. And I'm going to talk about something a little different, of course. So, let me tell you a little bit about myself. I've sort of spent about 15 years in the research community and about 15 years doing startups. I'm an old guy. In the research world, the first thing I did was I invented virtual memory, only to find out that it was already invented by 5 or 10 years. And that's something that happens to people a lot. And so, I think reinventing things and making sure that you are doing something new is one of the real issues. People ask me, well, you invented SMTP, right? And I say, no. What happened was somebody had this big design called MTP, and I was given the job of implementing it. And I looked at it and I said, this is hopeless. This has too much stuff. Let's rip a bunch of stuff out. And so that's how we got SMTP, which is actually simple MTP. And that's what we use today for email. And simplicity is one of my big things. I didn't invent the idea of putting S on the start of protocol names either. There were these guys that did TFTP, the Trivial File Transfer Protocol. But simplicity is a big deal. So at any rate, in the research community, I invented the DNS. After a bunch of time in the research community, I went to do startups at home, which was the first internet over cable. And I think that taught me one fundamental principle, and that is that you don't want to do a startup where everybody thinks you have the right idea. And what does that mean? There were tons of people that told me that doing internet over cable would never work because cable is too noisy. Cable is still too noisy, okay? But digital signal processing and Moore's Law just came along and said, yeah, we'll filter out the noise and and we are where we are today. So, being a little bit counter to the prevailing wisdom is something I think you have to be. Software.com, which got merged into something, and that was a startup that taught me I could make more money shorting the startup than I could actually owning equity. Because I was on it early on and they wanted to go off in a bizarre direction, and I said, fine, I can sell my equity, I can short the stock, life is good. I went to a company that fiber lane Sorrent Sierra because it had a civil war and broke into pieces. And that was doing packets over basically Sonnet, which is one of those bellhead technologies. And you might say, well, gee, if you're an internet guy, why were you doing stuff over bellhead technologies? It was because they had a few $100 billion worth of the stuff in the ground and wanted to send packets over it, and I figured they would pay, and they would. So, you got to figure out sometimes that you're going to work with other people, even people that you might not want. Urban Media taught me that I could incinerate about $100 million worth of investors' capital. I had asked to do a $5 million startup, and they said, no, you can't just do it in 2 cities, you have to do it in 30. And I said, but that's going to cost an awful lot of money, and we're not sure it's going to work. And they said, we don't care, get big or go home. At any rate, and then there's Nominum, which is where I came back to DNS. So I had this whole sandwich here of research, startups, and then back to some of the research DNS stuff. So I'm going to talk mostly about that. The origins of the DNS, part of it was that in 1983 there was this big switch from first generation internet technology to second, and that's sort of from all the ARPANET guys you've heard to the internet guys. And they were changing to TCP and IP and all of that. And What of course happened is people said, well, if we're changing that, let's change everything else. So they changed the way file transfers work, mail, blah, blah, blah. So I had, just got my degree, and they came to me and they said, here's 5 proposals for how we should do naming in the new internet. What we want you to do is to, read them all carefully and put together a compromise. Okay, now I couldn't do that. Why was that? Well, one of it is that at least 2 of the proposals were much too complicated for me to understand. And I didn't like any of them. But the great thing about this is a nice little job, while the important people in the internet worried about how would we put card images over TCP connections. So I could do pretty much what I wanted, and I just went off and invented something new. Because I didn't think any of the stuff would work, and I didn't think anybody was watching. So, eventually some of those people came back to me and said, you didn't use much of my stuff. And I said, oh, yeah, I'm sorry, I used all the other guys' stuff. And they actually didn't figure it out for 10 years. It was really great. There's this question about rules learned, and I'm going to talk about some of my principles.
I say we take off and nuke the entire site from orbit. It's the only way to be sure.
Okay, so this is an example of a problem you run into in a startup. Okay, there's some point where you have this profound difficulty. And you have a bunch of people who are looking at you saying, how am I going to deal with this difficulty? For those of you who haven't seen the movie Alien, don't go on a vacation on any planet that starts in the LB 400 series. But, basically there's, a problem that Ripley is facing where there's this sort of carnivorous thing that wants to kill all the humans. And there's a bunch of people that are saying, oh, no, what we really need to do is to take samples to bring back and do all kinds of complicated analysis and figure out a strategy. And she's saying, how about we take off from orbit and nuke them? Which is kind of a simple solution to the problem. Simplicity, I think, is the #1 rule here when you're trying to design a system or do a startup. Don't be clever if you don't need to be. Part of the thing that I avoided doing when I was inventing the DNS was I didn't do most of the implementation, even though there's a lot of biographies that say I did. What I did was I gave people an opportunity to be the lead implementers for Unix. And the Berkeley and the Stanford guys, among a bunch of other guys, competed. I didn't write a line of that code. But what I did is I managed to get a stable version running on a large time-sharing system of the time and managed to get a bunch of people working on doing implementations, because they would all say, hey, I did the Unix implementation. Hey, I did the this and the that. So, don't be clever if you don't need to be. The customer needs to understand the interface, not the inner workings. Today at Nominum, we build DNS servers that we sell to carriers. And then there's about 500 million people on the planet who, when they ask for www.whatever, go through our servers in order to get that resolved. And there's a bunch of people who, the people that the cable companies and the phone companies hire to run this stuff don't really understand the inner workings of the protocol and the round trip times and all that kind of exotic stuff. The way we made a successful business when we were competing against free software, right? It's hard to compete against free software on price. That's a big problem. But what we did is we went to the telcos and we said, oh, you need something that never stops. You need to be able to change the configuration without rebooting it. Because like when you reboot the open source, and you have to wait for somewhere between 10 minutes and 2 hours, depending upon how big the configuration file is for it to start up. They say, we don't like that, because then people start calling our customer service. And every time customer service gets called, it's like burning a $20 bill. So we basically were providing simple facilities that the customer wanted, and we were doing it with a pretty simple implementation. I guess the last point I want to make here is your plan already has a flaw or two. Ripley doesn't know that actually there's one of these carnivorous aliens that's in the ship that's going to help, and but she has to adapt. Don't create problems. Don't try and use exotic technology when you don't have to. All right, the next lesson, which is a little bit related.
When you believe in things you don't understand and you suffer.
Okay, This is one of my favorite quotes because, I just tell people that, I have a architectural expert called Little Stevie Wonder. And, when you believe in things that you don't understand, when people explain something to you and you're kind of going, I'm not quite sure I get that. Should you trust? Well, you should trust and verify, as Ronald Reagan said. I think that one of the big problems that people run into is, you can run into, I'm going to offend some people in the audience, you can run into these agile programming people that say, oh, we don't need a plan, we'll just start implementing and listen to the customer. I'm sorry, you need a plan, and you need a plan that you can explain. Because if you can't explain your plan, I don't think that means that you really understand it. So, applying that, we had a very simple start to DNS. People say, well, there wasn't any security in the original design. And I say, no, there wasn't. And there wasn't any incremental design. I say, no, there wasn't. Blah, 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 blah. There's all these things that, were flaws that I didn't put in that. Well, I look at it as, when the Wright brothers flew their first plane, they didn't have a drink cart, and they didn't have a bathroom in the plane, and there were all these other features. It's important to get the simple, basic things right and get an early implementation out there. The security people who have been working to add that security stuff to DNS, I don't know if it's somewhere between 15 to 25 years, depending upon how you count, that the security people have been trying to do that. And they always have perfect plans, and they always take longer to create a perfect plan than it does for circumstances to change. And what I mean about that is, supposing you were trying to sell security services on 9/10. Okay. Supposing you were trying to sell them on 9/12. Well, 9/11 kind of changed a lot of the rules about that. Particularly when you're getting into these policy kind of issues. You got to figure out how to do something quick rather than something perfect. Another thing about understanding what you're doing, there's this type of development which I call Monte Carlo development, where people don't really understand how to do something, but they kind of like, well, the C code compiles, let's see what happens. And the problem with that is you got to realize that complexity is your enemy. I draw this curve that looks something like this. And what I'm trying to say here is that in the lower triangle, where you're saying that you're not complexity, you get smarter over time, so you can approach more and more complicated problems. You have better tools, faster processors, all these kinds of things. So the amount of complexity that you can handle increases with time. But the problem is that when you're right at the edge, which is usually where the marketplace drives you. One of the problems I work at the university is routing and BGP and all of that kind of stuff. And people always talk about, well, we're almost to the edge of our understanding. No, we've driven it right to the edge. And people are over into that red zone where they actually don't understand the implication of the changes they're doing. And there's no bright line there. Sometimes you try and do something and you don't understand it and you happen to luck out. But in most cases, it doesn't work. So I think that what you ought to do is to understand what the limit is that the marketplace is forcing you to, which is typically higher, and stay just below that where you don't understand what you're doing. I think the last part here is to plan for extension. The DNS was something that I invented, and one of the questions people ask me is they say, well, when you first invented it, did you imagine that it would be used for the things that it's used for today? For example, keeping track of cows in North America via RFID tags. Well, no, I hadn't figured that out. In fact, I think that if you understand totally what your system can be used for 100%, it's not a very interesting or powerful system. You have to figure out how to build something that other people will build on top of. In VC parlance, you want to build a platform, all right? This is the essence of it, because people are going to come along after you. Now, the flip side of that is the future will, extend and desecrate your baby, which is kind of a brutal way to say it, because people do all kinds of offensive things with the DNS today. And they do all kinds of wonderful things with the DNS today, and I just have to live with it. In fact, one of the things that we're doing today, seeing as we have 500 million customers going through our DNS servers, we're trying to figure out how to use the DNS as a sensor network. In other words, you can sit there and say, well, okay, what websites are people going to? You can also figure out whether or not they're infected with particular viruses. So it's interesting, you know, we did some looking at some of the statistics of some of our user base just to see, you know, we found out that users in the Department of Defense didn't seem to have any flame infections. Do people out here know what flame is? Flame is the son of Stuxnet. It seems to be this virus that was, you know, it seems to be infecting computers mostly in the Middle East. I don't know who would want to do that, and not so much elsewhere. But the point is that we're using DNS as a sensor network, and we've now, the next generation of stuff, we had DNS as an open platform. Today we're doing DNS as an open sensor platform where we're building applications on top of it so that we can help you detect and defend infections and do a variety of other measurement kind of things. Now you might say, well, gee, you know, you're invading the privacy just like everybody else is who's tracking you with cookies and so forth. Some of it, you know, there's always the possibility of misuse, but you know, we think that it's the best way to measure it. And if anybody here has any great ideas about what they might do there, we're trying to create some open APIs and room for experimentation. So that's my prepared remarks. If you guys have any questions, I'll be happy to deal with them. But that's it. Thanks very much.